This is part 2 of lesson 4.4, solving systems by elimination. Continuing on in number 8, our system, we have nothing that's going to easily be eliminated, so we need to figure out what we could make happen. So the whole thing with systems of equations that you're solving by elimination is you're trying to create the desirable situation. So look at your x's. Is there something you can multiply one or both of them by so that they would be opposites of each other? So this one is not too hard to see what it is. You could multiply this by positive 4, giving you a 4x with a negative 4x. That would be great. So we're going to do that, but before we do that, let's talk about some other things we could do. And so just kind of getting creative here. I could multiply this by 12. What would that do? Well, what that would do is it would give me negative 3 on the y, and that could get rid of that. Now, do I necessarily want to do that? Well, it's debatable, so you can do it if you want to, but most people are just looking for like something pretty simple, so we're just going to go ahead and do that first thing that I said. If you want to try some other things, that's fine. You want to make sure that you check your answer to make sure that it works the way you thought it would. I'm going to add these and get rid of the x's, so that's eliminated. I've got positive 3y, negative 3y. Make sure you watch your signs here. 10 plus 2 is 12. And then I'm going to solve for y, so y is equal to 6. So in my ordered pair, I'm going to put 6 for my x. Then I'm going to put this back in. Now, do I want to plug it in there and do 1/4 of 6? Probably not. I'm going to put it into the top one. So negative 4 times x plus 3 times 6 equals 10. Negative 4x plus 18 equals 10. So subtracting 18 from both sides, x is equal to 2. Now I would have gotten that same thing if I would have plugged it in to the second equation. And we can try that just to make sure, just to show you. If you did x minus 1/4 times 6 equals 1/2, you're going to have x minus 6/4 equals 1/2. If I add 6/4 to both sides, I'm going to have 1/2, which is 2/4, plus 6/4, and so x is equal to 8/4, which is 2. So it's the same thing, and so I've got the correct answer. So with systems of equations with elimination, like I said, you're just going to want to try to find something that you multiply to create a situation where you have opposites. So looking at number 9, before you get too excited about about changing things to be eliminated, you need to notice on this one, notice how things are not lined up. There's your y's, there's your x's, there's your constants, there's your equals. Before you can do anything, all of the things have to be lined up. All the x's, all the y's, all the equal signs, everything. So I'm going to have to rearrange some things. If we put this into standard form with the x and the y on the same side, I could move my 6x to the other side. I would keep my 30y, and I would move the 6 to the right-hand side. That's exactly the same equation, but it's in what we call standard form. And then if I do the second equation in standard form, I'd have to move this x. So I'd have negative x plus 5y equals negative 1. So again, watch your signs, but once I have that, then it's something I can actually do something with. So think about options. I could turn those into a 6 and a negative 6. Make sure you pay attention to your signs, because if you just multiply that by 6, you're not going to have opposites. And so I'm going to take my first equation, I'm going to rewrite it. And I'm going to take my second equation, and I'm not going to multiply just by 6, because that won't give me opposites. I'll do negative 6. So negative 6 times negative x, negative 6 times 5y, negative 6 times negative 1. So when I add those together, x's are eliminated, y's are eliminated, and the constants are eliminated. So that gives me an infinite number of solutions because I have the exact same equations. So I'm going to write infinite number of solutions. And that just means, remember, that we've got the same lines if we were to graph. They would intersect at an infinite amount of points, but not all the points. So don't say all real numbers. Okay, on number 10, 10 through 13, we're going to check these 4 points and find which system each one is a solution to. And so if I want to see if this is a solution to that system, how could I do it? How could I find out if it's a solution to any of those systems? And so what you're going to do is you're going to plug in and you're going to find the system that that one is going to be a solution for. And so you can just start by plugging in, and so I'll show you the first one. If I take this is x and this is y, and to start out, you know, you might as well just pick one. So I'll just start with number 10, so I'm going to plug it in. So negative 2 times x plus y, is that equal to 3? And so I start with that one, and I can see right away that that is not equal to 3. So that means that this one is not a solution for that number 10. So I'm not even going to do the other equation in number 10. I'm going to move on to number 11. So moving on to number 11, negative 3 times y minus 4 is equal to negative 2 times x. So that's 6 minus 4 equals positive 2. That works. So now I have to check the second equation. 2 times x plus 4 equals negative y. So negative 2 plus y equals negative times negative 2 is positive 2. If I, oh, that's a 4. Negative 2 plus 4 is equal to 2. So 2 is equal to 2, and that's true. So actually, A is a solution to number 11. So I'm going to put A right there next to that. So you're going to try the other ones and match up the other points with their system of equations. Okay, hopefully you plugged all of those in and found which one each one was a solution to. So 10, C is the solution to that one. 11A we found, 12 is D, and 13 is B. Okay, we're going to solve some systems of equations this time, and you'll notice that we're going to do the same things that we did before. We're going to define our variables, write the system, but this time we're also going to solve. When you have story problems like this, elimination is often the best way to solve it, because when you have your variables, they're usually set up in that standard form with the x and the y on the same side. So to solve an equation by elimination is going to be a lot easier in most situations. So it says on number 14, 3 times a number added to another number is 18. So I've got two numbers added together, and it's going to be 18. Twice the first number, so 2 times the first number minus the second number is 12. So find the two numbers. So first of all, defining my variables, what are the things I don't know? I need a first number and I need a second number. And you're not just going to say x equals a number and y equals a number. That doesn't make any sense, because does that mean they're the same thing? So you're going to say x is equal to the first number and y is equal to the second number. So you have to distinguish that you've got one number and then a different number. So if we take the first number plus the second number, it's 18. That's our first equation. Now take the second sentence. It says twice the first number, so that's going to be 2 times x, minus the second number is 12. So that's my equation that I have, my system. And so now that I know how to do elimination, I can solve this. So this was number 1, this is number 2, and now for number 3, I'm going to solve that. So if I look at my y's, notice how they can be eliminated. And so all I have to do is add them together. The y and the negative y is gone. 12 and 18 is 30, so x is equal to 10. That means that the first number is equal to 10. And so you're going to write that out. Don't just say x is equal to 10. Tell me that that's the first number. If the first number is 10 and we add it to something else to get 18, we know that the second number equals 8. And you're just finding out by plugging in right there. So that's how you would do that if you didn't know that off the top of your head. And then that's your third thing that you have to find. So define your variables, write your system of equations, and then solve using elimination. Okay, the next one, it says you empty your bank, which is 63 coins, into a coin counting machine. You only have nickels and quarters. The value of the money is $8.55. How many nickels, how many quarters? So we're going to have nickels and quarters. I know their worth. I don't know how many I have. So N is going to be the number of nickels, and Q is going to be the number of quarters. Now I do know about the number of nickels and the number of quarters is when I put them together, how many coins do I have? Now let's talk about the value, their worth. I know that together it's $8.55. So what are they separately? With just the nickels, I'm going to take 5 cents times however many nickels I have. So remember when we write the value of a nickel, It's not 0.5, it's 0.05. That's the number one mistake people make on a problem like this. The value of a quarter is 0.25, and then $8.55. So looking at that, that's my system. So here's, again, 1, define your equation. 2, come up with your system. Now 3, to solve this, you're going to have to make either the ends eliminate or the q's eliminate. So you could multiply this top one by negative 0.05, or you can multiply it by negative 0.25. Both of those things would work. Another thing that you could do is you could multiply this top one by negative, well, you could do negative 100, and that's going to get rid of your pennies. You would have negative 5n minus 2525q equals, and multiplying 8.55 by 100 is 855. And then you can deal with the n's and the q's a little bit easier. So you can see, like, if you just multiplied the top one now by 5, that would work. You could also multiply the bottom one by negative 500. So a lot of that's going to come from how well do you understand how decimals work, but those are some options. I think the easiest thing probably is just going to be multiply the top one by either negative 0.05 or negative 0.25. You're still going to have decimals if you have that, but it's okay because we can use a calculator to do that, and it's not that big of a deal. So I'm going to have negative 0.05n minus 0.05q equals, and then 63 times negative 0.05 is negative 3.15. And then the second one, the second equation, I'm just going to rewrite that. Don't lose your decimals. And then I'm going to add them together. The ends are going to be eliminated. Negative 0.05 and positive 0.25 is 0.2 or 20q. And then 8.55 and negative 3.15 is going to be 5.4. And then I divide both sides by 0.2. And that means I'm going to have 27 quarters. Now remember that you can't have parts of quarters. You either have 27 or you have 28. There shouldn't be any decimals when you're finding out how many quarters and how many nickels. So if you get like 27.8 quarters, you know that something is wrong with that. So we're going to have 27 quarters. And so how many coins are left to be nickels? So I know that added together is 63. So you just do 63 minus 27. And you get 36 are nickels. Now if you check this, do 27 times 0.25, that's how much your quarters are worth, and do 36 times 0.05, that's how much your nickels are worth. That should be equal to $8.55. And so this is your answer. So that's the third thing that you need to do. Before I end this, I want to go back to number 9 because I want to talk about a question that people have that's pretty common. Let me go back to where I had the equation set up in standard form. So I had moved things around, and so this is what I had. A question that's often asked is, couldn't I just multiply this by 6? So I would rewrite my first equation and my second equation. And then the question is, couldn't I just subtract it instead of adding it? So couldn't I just do minus negative 6? So negative 6 minus negative 6? That does eliminate. So the answer is yes, you could. Here's the danger in doing that. The danger in doing that is people forget that they would also have to subtract that, and they would also have to subtract that. And that's the problem. So as a result of that being an issue, I never say that you should do that. I always say you want to make it so that the numbers are opposite so you can add them. If you are going to mess around with subtraction, you're probably going to get messed up. So it's not that it doesn't work, but just because something does work doesn't necessarily mean you should do it. So I recommend not subtracting. I recommend just doing the addition. That concludes lesson 4.4.